So right now, we have this strange visitor passing through our solar system, an object from a distant star that's behaving in ways that, well, challenge our most basic understanding of what a comet is. Let's dive right into this cosmic mystery, shall we?
The whole thing with this object kicks off with one single, baffling question. What if a comet's tail pointed the wrong way? And I don't mean just a little bit off angle. I mean pointed directly towards the sun. That's the puzzle we're digging into.
All right, so this object is called 3I/Atlas, and it is definitely not from around here. Yeah, it's a traveler from another star, and honestly, it seems to be playing by a completely different set of rules. So you might be asking, how do we know it's from another star system? Well, the data is pretty conclusive. It's only the third one of these things we've ever found. For starters, this thing is moving at a blistering 57 kilometers per second. I mean, just try to wrap your head around that. And its path, its trajectory, is what we call hyperbolic. And that is a huge detail. Basically, it means it's moving way too fast to get caught by our sun's gravity. It's on a one-way trip, just passing through the neighborhood. You know, because it's such a rare interstellar guest, you can bet scientists were watching it very closely. And that's when they spotted something, well, something truly bizarre. Something that kicked off a whole wave of new ideas and debate. Its tail. Okay, let's just break down the core problem here. See, a textbook comet is pretty simple, right? The sun's energy pushes dust and gas away from it, so the tail always points away from the sun. Always. But with 3I/Atlas, astronomers saw something that just shouldn't happen. A really prominent tail pointing directly towards the sun. Wild. So yeah, this anti-tail immediately set off alarm bells. I mean, was everything we knew about comet physics wrong? Or was there something else going on? So scientists got to work modeling this thing, and a really compelling natural explanation started to come together. The leading theory really boils down to this process called sublimation. Okay, so here's how it works. The sun heats up the comet's surface, but instead of melting, the frozen carbon dioxide on it just turns straight into a gas. It's violent. So this CO2 gas then erupts in these super powerful jets. And these jets basically act like a rocket, and they push all these lighter water ice grains forward, towards the sun. And from where we're standing, back here on Earth, that jet of icy particles, it looked just like a tail pointing the wrong way. And here's the kicker. This sunward tail wasn't a permanent thing. That's a huge piece of the puzzle. We only saw it when the comet was at a very specific distance from the sun. As 3I/Atlas got closer, the physics started to change, and that tail began to swing around into a more, let's say, normal direction, pointing away from the sun. It's incredible. It's like we're watching a real-time physics experiment unfold right in front of us. But you know how it is in science. Just as one mystery starts to get solved, another one pops up. Turns out the tail wasn't the only weird thing about 3I/Atlas, not by a long shot. When astronomers took a look at the cloud of gas and dust around it, what we call its coma, they found a really, really peculiar chemical cocktail. Yeah, its chemical fingerprint is just not what you'd expect. For one, it has one of the highest ratios of CO2 to water we've ever seen. That suggests it probably formed in a super cold, really distant part of whatever star system it came from. And on top of that, it's showing really high levels of nickel, but weirdly low amounts of iron. That combination just doesn't quite fit the mold. Now, these things aren't impossible for a natural comet, but they're definitely rare enough to make scientists start asking some much bigger questions. And of course, those bigger questions inevitably lead to the big question. Is 3I/Atlas just a really strange natural comet from a different kind of star system? Or could all these oddities be hinting at something else entirely? Let's take a look at the two big ideas on the table. Okay, so on one side, you have some scientists, and they're treating this as a serious thought experiment, who've suggested that maybe these oddities could be interpreted a little differently. From this perspective, that sunward tail might not be a natural jet at all, but maybe a controlled release of material. And that weird chemistry could be byproducts of some kind of technology. Now, it's super important to stress, this is speculation. It's a way of asking what if. But then, on the other hand, you have the vast majority of the scientific community, and they're pointing to a core principle of science. Extraordinary claims require extraordinary evidence. And as of right now, there's just zero direct evidence for an artificial origin. All the weird stuff we've seen, while definitely unusual, can be explained by natural processes we already know about. So this table kind of breaks down the debate pretty neatly. For the Sunward tail, you've got the CO2 jet model on one side versus the idea of a controlled release on the other. For its composition, it's either the chemistry of a different star system or its technological byproducts. But really, the bottom line here is the evidence. The natural origin theory has a physical model that actually fits the data we see. The non-natural theory, well, it currently has no direct evidence backing it up.
But here's what I think is the most important takeaway from all of this. Look, no matter where it came from, natural or not, 3I Atlas is an absolutely incredible scientific discovery. It's a messenger from a distant star system, and it has so much to teach us.
I mean, this is a total landmark case study. It's showing us just how incredibly diverse interstellar objects can be. We're getting brand new data to test and refine our models of how comets even work. And it's basically a direct sample of the chemistry from another part of our galaxy. And maybe more than anything, it's just this powerful reminder that the universe is so much stranger and way more full of surprises than we can possibly imagine. And you know what? The story is not over, not by a long shot. 3I/Atlas is still being tracked as we speak, and scientists have a very specific watch list of things they're hoping to see as it keeps on moving through our solar system. So what's on that watch list? Well, first they're going to be glued to their telescopes, monitoring how that tail continues to change as it gets closer and closer to the sun. They're also measuring exactly how much dust and gas it's spewing out to see if those rates change. And this is the big one. They are looking for any tiny unexplained wiggles in its path, any kind of non-gravitational acceleration that might hint that some other force, something besides the sun's gravity, is pushing it around.
In the end, 3I/Atlas is going to go down as a landmark case in our effort to redefine what a comet can even be. It just showed up in our backyard and completely broke the rules we thought we knew. And that kind of leaves us with one final tantalizing thought, doesn't it? What other cosmic mysteries, what other rule breakers are out there right now just waiting, just beyond our reach?